election. You have to do that by tomorrow, is it? I think it's tomorrow.
Yes. Yeah. Oh, no, today, actually. So just you're casting your vote today for the election. And it was sent to your Gmail, your student Gmail account.
Yeah. And looking at tomorrow is your Chapter 3 test. So we're going to review today. We're going to have a lot of time for everyone to work independently, and you can ask questions. So for cohort 1, who will be virtual tomorrow, make sure you have 2 devices. You are going to have 1 device so that we can see you taking the test, and then another device for you to take the test on your iPad. Some tips for taking tests. If you're confused on a question, don't sit there and spend 5 minutes on it because the time is very valuable. So you don't know what to do, skip it, maybe come back to it, maybe you'll remember then, looking at different questions and reminding yourself of the other skills that we learned in this chapter. So that's all I have for you. Let's go over to that practice worksheet. We are going to look at number 15. It was this worksheet. I'll give you a second to pull that up. It's talking about tickets at a football game and attendance.
This was the worksheet that was due yesterday, in case you're confused. I saw a lot of miscorrectly represented matrices from this problem, so that's why we want to discuss it.
So this problem said, we have tickets to the football game that cost $2.50 for students, $5 for adults, and $4 for senior citizens. Attendance for the first game of the postseason was 120 students, 185 adults, and 34 senior citizens. Attendance for the second game of the postseason, and they gave us our attendance for students, adults, and senior citizens. We want to use matrix multiplication to find the revenue from ticket sales for each game. So we are going to think about this with two equations. We have the first game, and then we have the second game. So we also have students, adults, and senior citizens. So I'm going to go ahead and label our students X, our adults Y, and our senior citizens Z. So we have 3 different variables that we are taking account for. So if we want to make an equation to represent the revenue for the first game, how should that look? We don't know what our revenue is. That's what we're trying to solve for. So we have students, adults, and senior citizens. 120 students came to the first game. Go ahead, Jaden.
You would have 120x plus 185y plus 34z.
Good. So, Z. So, Jaden, do we know what the cost of each of these tickets are?
Yeah, the students is $2.50, the adults is $5, and the senior citizens is $4.
Yeah. So that's exactly what our X, Y, and Z are going to be here. So Jaden, what would an equation look like for the second game?
You would have 150x plus 210y plus 50z.
Good. So here we are lining up our attendance with the cost of that ticket for that individual. So here we know that our first matrix is our coefficient matrix. What are your coefficients here? Ava R., could you tell me what our coefficients are here?
Yeah, so it would be 120, 185, 34, and then on the next line it would be 150, 210, and 50.
Awesome. And what did these numbers represent again? What were they talking about? Is it the cost of a ticket? Is it attendance?
Didn't those numbers represent the attendance?
Yeah, the attendance. So this is talking about attendance. Now, Jaden told us we are going to take that attendance and multiply it by X, which we said is the cost of each ticket. So our 120 and 150 represented X, Y, or Z. Ella, did the 120 and 150 represent students, adults, or senior citizens?
Students.
Good. So if our first number in our rows here represented students, then our first number in this matrix better represent students as well, because they're being multiplied. And the cost of a ticket for students is $2.50. Our 185 and 210 right there represented the number of adults. We said an adult ticket was $5. So I'm going to write 5. And lastly, senior citizens. That ticket cost $4. And these are the two matrices we would multiply together to figure out what our revenue is. We know the first game, there was 120 students, and we know the price of the ticket. And we know the same for the adults and the senior citizens as well. So that's how you would multiply those two matrices. The first matrix represented attendance, and the second matrix represented the ticket cost. So then when you multiplied those two matrices together, you would have 120 times 250, 185 times 5, 35 times 4. That would be the revenue for your first game. And you would do the same for the second game. And when you multiply those through and add, you will get 1,361 and 1,625. And what did that equal? That equaled our revenue. So the top number, our 1,361, is our revenue for the first game. And the 1,625 is revenue for the second game. Questions on that? Madison.
Do you have to set it up in the equation form? Because I didn't do that, but I got the same answer.
Yeah, you don't have to set it up in the equation form. It helps you understand what you're looking at, sometimes if you're confused, I like to revert back to there and try and think of an equation in my mind, then take that equation and make it into a matrix. But no, if you understand what needs to be multiplied and how your first number in your row on your first matrix, this number, which is our students, when you multiply it, also has to be for students, then you're fine. And then same for adults and senior citizens.
Okay, I was just wondering if we would lose like points for not showing our work if we didn't do that.
So this is, as long as you are showing what two matrices you're multiplying together and you show something at this step, what numbers you're multiplying together, then you showed your work.
All right, thank you.
You're welcome.
And then the other thing to note is the matrices must be able to be multiplied together. So remember, those two middle numbers have to match up. So the first matrix is 2 by 3. The second matrix is 3 by 1. That's why you can multiply them. So if your matrices do not look like this, and I made comments to probably at least 12 of you on your homework yesterday, if your matrices aren't set up like this, then the problem would be marked incorrect. But like those equations that Ms. Karp has set up, like that's kind of helps you see how your matrices should be set up. So just make sure you're looking at that problem and see how you set up the matrices, because I did comment on a lot of you and the way your matrices were set up for that problem.
Yeah. Great way to double check before you go and multiply, look at your dimensions and see what your matrix would look like after multiplication and make blanks. All right. So then we are going to head over to Google Classroom to get the review for today. And we are going to work through a few problems together, and then I will give you the rest of the time to work individually and ask questions. You can hang on, ask questions, or just work independently. Once someone sees the review worksheet, let me know it's on there.
It's on there.
Cool, thanks, Faith. All right. The first section I want to look at is the bottom of this first page. So it talks about classifying the system as consistent and dependent, consistent and independent, or inconsistent. So I just want to talk briefly about what each of these mean. We know that we are given two lines. And then when we are solving, we're going to find a solution. We're going to find no solution, or we're going to find infinitely many solutions. So what does consistent and dependent mean? Who can tell me what that means about the lines? Ella, go ahead.
They're the same line, like they have the same equation.
Yep. So how many solutions would they have if they're the same line?
Infinitely many solutions.
Awesome. IMS, infinitely many solutions. What about if they are consistent and independent? What does that mean about these lines? Julia, could you tell me what consistent and independent means about these lines?
Does it mean that there's exactly one solution?
Yeah, there's going to be one solution. That means the lines are going to intersect at one point, and that one point is our solution. Good. And then lastly, if the system is inconsistent, what does that mean? Faith, what does it mean if the system's inconsistent?
There's no solution.
Yeah, there's no solution. What does that mean about the lines?
They're parallel to each
Yeah.
other.
Good. So once you go through and solve these systems, there's a little cheat sheet to help you remember how you would classify them. All right. Now we are going to jump to number 13 at this problem. So it says, Jake Garcia opens a music shop in which he will sell guitars and basses. He wants to find out the maximum amount of money he may have to borrow to purchase the instruments. Let X be the number of guitars and Y be the number of basses. So we know what each variable represents here. Part A says Jake's store is small, so he can buy no more than 54 instruments. We have guitars and we have basses. He can't buy more than 54 of them. How would we write an equality to represent that? Gabby Soul, how would we write an equation to represent this? Any equality?
Y plus X is equal to or less than 54.
Awesome. Because when he buys both, it can't be any more than 54. Good. Part B says, because guitars are more popular than basses, the number of guitars must be at least twice the number of basses. So think about this. What do we have more of? Guitars are more. So we know the sign would be opening towards guitars. Grace, could you tell me what this inequality would look like?
Would we do X is less than or equal to, I meant greater than or equal to 2Y?
Exactly, yeah. We know that the guitars have to be more than double the amount of the basses. Exactly. Great. Questions on that? And then lastly, what are our two obvious inequalities for this problem? Ava M., what are our two obvious inequalities?
X is greater than or equal to 0 and Y is greater than or equal to 0.
Awesome. Yeah. So now you have all your inequalities for this problem, and then you would go ahead and graph and find that maximum amount. So I will let you finish that, but now you have all of the inequalities. And then lastly, we're going to head over to number 16 on the back page of this about matrices. So they are just saying perform the indicated operation. Show work for matrix multiplication. So for 16, we have this scalar of 2 in front of our first matrix. Then we're subtracting another matrix. And that's equal to this matrix. What's the first step we should take here? Ava R.
The first thing you should do is multiply the 2 into the first matrix.
Yeah, so then what will that give us?
16, negative 2x, 10, and 12.
Perfect. We have that scalar out front. We're just multiplying it to each number. Then I'm just going to rewrite. So we have two variables here. What two equations should we set up to solve for those x and y's? Ella, what should we do next?
You have to subtract the second matrices from the first matrix.
Sure. So what will that give us?
It will give you 13, negative 2x plus 9,
Okay.
0, and 12 plus 4y.
Perfect. And that is set equal to the same matrix on the right. And we know that each number in each position are equal to each other on both sides for these matrices. And you can see that here. This 0 equals 0. They're both in the same position. We know we did that right. And same with this 13 and 13. So what are we left? What two equations could we make from this to solve for x and y? Riley.
You could do negative 2x plus 9 equals 4, and then 12x plus 4y equals 16.
Perfect. And then you can go through and solve for x and y. So I will let you finish that part. Questions on the problems we did together so far? All right. So the rest of the time is yours to work on this review worksheet. We are going to be here to answer questions. If you want to work through a problem, we can work through a problem together. If you're confused on something from chapter 3, now is your time to hang on and ask. But you don't need to stay, you are free to go. This review worksheet is due tomorrow. The solutions are on Google Classroom, so they are there for you to check. And your test is tomorrow. So make sure you log on to Zoom for the students at home at 7:20. You're going to want all the time for it, and have your two devices so we can see you and you also take it at the same time.
If you don't have a second device, log on a little earlier so that I can open the test for you and you can print it out at home, so that then you're using a piece of paper and your iPad as your device for your Zoom and camera. And then the second thing, please make sure that you take attendance for today. Please submit that attendance.
Yes. So that is all. So you are free to stay. You are also free to go. Good luck on the rest of this, and I will see you tomorrow.